Hello everyone. This will be a quite long video because we will be covering one of the most important aspects of the derivative, one of the most important types of applied problems, one of the two major types. We already covered one of them, related rates. However, our second one will be, or actually three applications. But our second type, probably the hardest type, is optimization. Now, you may or may not have done some sort of optimization when you had to deal with quadratic functions, where you would form a quadratic function and then find the vertex, and that would be your maximum value. However, in calculus, you have lots of different types of optimization problems, just simply due to the ability to take the derivative of lots of more functions and find critical points and just determine minimums and maximums. So what an optimization problem basically does is that you basically create an equation and then take the derivative of that equation with respect to whatever factor you're trying to minimize. Okay, so it's best done with a sample problem. So let's say we had a line. Let's say we had a line, okay? So we had the line y equals negative 2x, negative 2/3 x plus 2. Okay, so y equals negative 2/3 x plus 2. Excuse me. Now we're going to form a rectangle by having a point on the origin, a point on the line, and then drawing perpendiculars to each of the axes. So you have a rectangle that sort of looks like this. You have another one that kind of looks like this. This is also another candidate. And what my question to you is, what are the dimensions of the largest possible rectangle that you can make, the rectangle that has the largest area? So it is an area problem, the largest area. Okay, so the largest area, we need to find an equation for area. Okay, so we know the area equals length times width. So area equals x times y. Now, because area equals x times y, we have two variables. We can only have one. So why not eliminate one of the variables by performing a quick substitution? Well, we very kindly have this equation, the equation of the graph, and since this point is always on the line, that means y is related to x by the boxed equation. So we can make a quick and easy substitution. So x times negative 2/3 x plus 2. And you can distribute right now. Negative 2/3 x squared plus 2x. Now we can take the derivative with respect to x. So dA dx, dA dx. We take dA dx and we take the derivative. So we have negative 4/3 x plus 2. And now we want to set that equal to 0. Okay? Set that equal to 0. So you have negative 4/3 x equals negative 2. So negative 4/3 x equals negative 2. And if we multiply this, negative 3/4 you'll get 3/2. Okay? So we have our x value as 3/2. So it'll be about here. This will be our rectangle of the largest possible area. So if we were to take y, find our y, -2/3 times 3/2 plus 2, you would get, this all cancels out to -1 plus 2 is 1. So we have x equals 3/2 and y equals 1. So it's precisely this red rectangle, which is the largest that you can make under these conditions. You can kind of see it is the largest, right? You can see it is the largest that you can make. And we use calculus to find it out. That's the important part. Let's do a more geometric problem, shall we? So let's say this is a bit harder, but it shouldn't be that hard. Okay, let's say we had a sphere. This is our sphere. Oops, bad lines. So we want to find the dimensions of the largest cylinder that can be inscribed in the sphere. Okay? This is in 3D. And 3D usually means triple the trouble. Okay? However, using calculus, of course you can get it. Okay. So we have a cylinder inside a cone. Okay? So let's define some variables. Let the radius of the cone, the radius of the sphere be r. Okay? The radius of the sphere is r. This is also r. Now we have our height of the cylinder. However, since it's in the sphere, this plane cuts the cylinder in half since it's inscribed in there. So this will be h/2, where the height of the cylinder is h. Now the volume of our cylinder is pi r squared h, okay? Which means this length is r. This length is r, okay? So you have v equals pi r squared h. Okay, it's our h. Okay, so what do we do with that information? Okay, we know the radius of the sphere. Okay, so let's see if we can try to make some type of connection between the radius and the height, such that we can get the equation for volume of a cylinder all in one variable. Now, we know that the radius from the Pythagorean theorem, this is a right triangle. So the radius is equal to square root of r squared minus h squared over 4. Why? Because we just did the Pythagorean theorem over here. So we did h/2 squared plus r squared, little r squared, equals big R squared. Okay? So if we were to solve for r squared, well, we got this expression over here. And the reason why I'm solving for r, not h, is because the h would still involve a square root. Because r is squared, the square root disappears. So we get v equals pi times r squared minus h squared over 4 times h. Okay? And we can distribute. So we have pi h r squared minus pi h cubed over 4. Good. Good, good, good. So now we have the entire equation in terms of h. R, big R, is a constant. Okay, so do not let pi and r make it seem like there are more variables than there actually are. Because the only variable that is subject to change is little r and little h. The radius of the sphere will be constant. Okay? So why don't we take the derivative with respect to h? dv dh. Now, we just take the derivative, pi r squared minus 3 pi h squared over 4. Okay? Now let's get all this clunk out of the way. Okay, all the pi's we can factor out. So we have, and when we set this to 0, we factor out all the pi's. We have r squared minus 3h squared over 4. A lot cleaner. So all we need to do is solve for h. H squared, we have 3h squared over 4 equals r squared. So we have h squared equals 4r squared over 3, or h equals 2r over root 3. Or if you want to really rationalize the denominator, you have 2 root 3r over 3. Okay, so you know h squared is 4r squared over 3. So why don't we, so h squared over 4, h squared over 4, because we want to plug it in our expression for r to find the radius. So h squared over 4 will just be r squared over 3. Okay? Because this 4 just disappears when we divide it by 4. So r equals 3r squared over 3 minus r squared over 3, which equals 2r squared over 3, or root 6r over 3. Okay? So you have root 6r over 3. And that gives us our answer. That was a fun one. We'll do a couple more in some more videos because this is a pretty big topic.